Okay, this is going to be the second video on given an original function, how do you find the derivative of its inverse at some value of x? Now, if you haven't done it yet, I would watch the first video because when you look in your book, you'll see this rule. And in the first video, we developed this rule and talked about where it came from. And we also expressed this rule in words like this. What this thing says is that the derivative of the inverse function at some xi is equal to 1 over the derivative of the original function at some xo. And again, if you need to, watch that first video and you'll be familiar with where this comes from. Now, what we're going to do in this video is, rather than directly solving the problem using this method, what you'll find is in some cases, depending on the original problem, it may be easier to find the derivative of the inverse without using this method. So let's take a look at what that would look like. We'll actually put a second graph up here. And so we'll solve it two ways. We'll solve it a direct way here on the left, and we'll solve it using this rule on the right. And in both cases, we'll get the same answer. But I want you to see that in some cases that it's actually easier to solve it directly than it is to use this definition right here. So let's run through this and see what it looks like. Now, in both cases, the original function is f of x is equal to the square root of x minus 4. And if you graphed it, it would look like that. So this is f of x right here. And then over here, this is also f of x. So the blue function is the original function. And again, it's defined whenever x is greater than or equal to 4. So that guarantees it's a one-to-one function, and it's going to have an inverse. Now, what we want to do is this. In both cases, we want to find the derivative of the inverse at x is equal to 2. And the way we did this in that first movie, we called this the x-coordinate of the inverse is 2. So what that means is right down here, x sub I was 2. And over here, the x-coordinate of the inverse was also 2. And again, if you need to, watch that first video and you'll be familiar with all this. So, first of all, let's do it. Rather than using this method, let's talk about this. Suppose you decided to do it directly. There are some problems that it's easier to do it directly than it is to use this. And how do you know which one it is? And the answer is this. If you can do this, if you can take the original function and easily find its inverse, it's usually easier to solve it directly than it is to use all this rule over here. In this case, this function is going to be pretty easy to solve the inverse. So our approach will be this. Let's just draw a picture of it and kind of talk about it as we go through. The first step, given this way, here's the original function. The first thing we'll do is find the inverse of the original function. And if we did that and graphed it, it would actually look like this. So again, the inverse is just a reflection across that green line. So this would be the inverse, and we're going to call that g of x. So that's going to be the inverse function. Now, what the problem says is find the derivative of the inverse function at x equals 2. Well, the derivative is the slope of the tangent line, so you want the slope of the tangent line at this point. So let's go ahead and put that on there. So what you're looking for is the slope of this line, and graphically what that is g prime of x, and it's equal to, we'll put a little question mark here, it's equal to what? And that's what you're actually solving for. So you want to find the derivative of the inverse at the point x is equal to 2. Now, the approach to solving will be to do this, is just take the original function, first of all, find its inverse, which will give you this red graph, then find the derivative of that inverse, which will give you the slope of the tangent line, evaluate the tangent line at the point that you're interested in, and you'll have the answer. So it's going to be a pretty easy process. Let's just go ahead and do it real quick right here. So let's go ahead and call this, we'll call it method 1. So what method 1 is, and let's call this one the direct method. You're just going to go directly to the inverse function and find its derivative. So if you do it this way, kind of a three-step process. So step number 1 is going to be to find the inverse. So you want to find the inverse function, and that's what we're calling g of x. Now, to find the inverse function, start with the original function. So that original function was y is equal to the square root of x minus 4. Now, in this case, finding the inverse is pretty easy. And you might remember from your algebra days how to do that. You interchange the x's and the y's and solve for the new y. So where you've got a y, put an x, is equal to the square root of, well, you've got an x, put a y, and that's going to be minus 4. So now solve this for y, and you'll have the inverse. So square both sides, and you'll have x squared is equal to y minus 4. And we'll scoot this thing down a little bit. And then add 4 to both sides, and you'd have x squared plus 4 is equal to y. Now what that is, that's going to be the inverse function. So in this case, we've got g of x is equal to x squared plus 4. So that's the inverse function. Now if you look back up at your graph, that is this red function right here. So what you want is the derivative of that inverse function. So we go to step 2, and step 2 says, now that you've got the inverse, just go ahead and find the derivative. So if you're using this direct method, now that you've got the inverse, step 2 says find the derivative of the inverse. And that's also going to be pretty easy to do. So to find the derivative of the inverse, just take the derivative of this. So g prime of x, and using the power rule, the derivative of this thing would be 2x. So now you've got the derivative of the inverse. Now, the last step, you want to know what's the value of the derivative of the inverse at x is equal to 2. We'll look at the graph up here. So when x is equal to 2, if you evaluate the derivative, you'll have the slope of that black line, and you'll have the answer to the problem. So let's go ahead and do that. So this is going to be step 3. So what step 3 is going to be to find the value of the derivative when x is equal to 2. So take a 2 and plug it into this derivative function, which would be 2 times 2, which gives you 4. And what that is, that's the answer to the problem. That is the value of the derivative at x is equal to 2. So what this means is that the slope of that black line is 4, and that's the answer to the problem. So it's pretty straightforward deal. So the idea is, given the original function, first step, find the inverse, which gives you this red line. Second step, find the derivative, which gives you the equation for the black line, the tangent line. And then step 3, to evaluate the tangent line, just plug it in. So in those 3 steps right there, very easy process, and led you to the answer. So in this case, and you were able to do all that because it was easy to find the inverse of the original function. So my suggestion would be, if you have a problem and it's easy to find the inverse of the original function, don't waste your time doing all this. Just do it directly, and usually it'll be an easier process. Now, if it's so easy to do it this way, why would you ever want to do it this way? And that's what we'll talk about now. Now, there are some cases in this. I say, if it's easy to find the inverse, do it the direct way. But there are some problems where it's difficult or maybe even impossible to explicitly find the inverse. And if that's the case, you have to do it this way. So let's do it. We'll go work ahead and work this same problem using this method. It'll take a few more steps, but we should get the same answer. The answer to this first one was 4. So should get the same thing over here. The answer should be 4, but we'll go about it a little differently. Now, the biggest difference is when you do the direct method, most of the work involves the red function, in other words, the inverse function. If you go about it this way, you're assuming that the inverse was hard to find, so you're going to do all the work on the original function. So let's talk about the process on this one. So going about it this way, the idea is that the derivative of the inverse function at x sub I is equal to 1 over the derivative of the original function. So the first step in this one will be, starting with this original function, we want to evaluate the slope of the tangent line. And if we do that, it'll actually wind up being this line right here. So if we can find the slope of the tangent line to the original function, then the derivative of the inverse function will be the reciprocal of that, or 1 over that. And again, that's what we did in that first video. So let's run through these steps, and we'll see what we've got on this one too. So we'll scoot this down just a little bit here. And the steps will vary just a little bit more on this one. So you're going to use this formula, and the first thing to do, this is going to be step number 1. So in this case, step 1. Now over here, the first step was to actually find the inverse function. Now, in this method, we'll never actually find the inverse function. We'll solve it by working strictly with the original function. So the first step here is to do this. You're going to need the derivative of the original function. So we will find the derivative of the original function, f prime of x. So if the original function was this, let's just go ahead and write it like this. We'll say that if f of x was equal to, and I'm going to write this as x minus 4 to the 1/2 power. So we'll write it like that. Now I want to find the derivative. So the derivative, and using the chain rule, it would be 1/2 of x minus 4 to the minus 1/2 power. Now I'm going to go ahead and write that. I think I'll scoot it down a little bit where I've got a little more room. We'll write this as f prime. So the derivative would be, here's the 1, here's the 2, so it's going to be half. Now since this is x minus 4 to the minus 1/2, I'll move it to the bottom and make it be x minus 4 to the positive 1/2. And then finally, I'm going to rewrite it one more time like this. The first derivative would be equal to 1 over 2, and I'll change that into a square root of x minus 4. So I've got the derivative, and that's this part right here. Okay, the next thing I need is, okay, at what value of x do I evaluate this? Now again, if you watch the first video, you'll be familiar with this. But let's go back up and look at our graph. And you really don't need the graph of the red thing, but sometimes it helps to put it on there. So let's go ahead and just put, if we decided to sketch a graph of the inverse, it would look like this. Now, I'm interested in exactly what I had over here. I think I'll go ahead and put the slope of the tangent line on right here also. So what I'm solving for is exactly what I had over here. This is going to be some g of x. Now, when I did it this way, I actually knew what g of x was. In this case, I'll never actually know what g of x is. But what I want to find is the slope of that tangent line, and the slope of that tangent line is the derivative of this thing evaluated at x sub I. And I'm still solving for the same thing. Now, since I got an answer of 4 here, I'm expecting to get an answer of 4 over here. But we're going to go about it a little differently. Now, this time you're going to find this. You're going to find the slope of the tangent line to the original function. Then you'll take the reciprocal of that slope, and that's going to give you this slope right here. So it'll be a different approach. But first of all, you've got to find this. Here's the original function, and here's the original function, here's the inverse. Now again, this point is going to be the point 2, and you can tell by the graph it would be 2 and 8, but let's assume that for a while that we didn't know what that was. Over here, I need to know this. I need to know where is the point of tangency of the original function. And to find that, you'll do the following. Remember that the x value here becomes the y value here, which means this point, if this x value is 2, this has got to be 2 right here. So the next step now is to find the x-coordinate of the tangent of the original function. You're solving for this. This one is given. The x-coordinate of the inverse was given, but you're solving for the origin. So let's go ahead and drop down and do that one. So what step 2 is going to be, step 2, and again, this is just like in that first video, so if you need to, watch the first video again. You want to find x sub O is equal to what? So the question is, at what value of x do you evaluate this derivative? So you're looking for this thing right here. Now to find it, you just take the original function and set it equal to 2. You set it equal to whatever x sub I is. So that's going to look like this. You've got y. The original function looks like this, is equal to the square root of x minus 4. And since y is equal to the x-coordinate of the inverse, that's where the 2 goes. So 2 is equal to the square root of x minus 4. And this is going to give you x sub O. So to solve this one, square both sides and you get a 4. And that's going to give you x minus 4. And add 4 to both sides and you'll get 8 is equal to x sub 0. So what that gives you, we'll go back up and look at the graph, that gives you this. You now know that this thing is 8. So, and there it is right there. So you've got the value of x sub o, so you've got this. Okay, the next thing you want to do then is to evaluate the original derivative at x sub o. So what that means is take this value of x sub o and plug it into this derivative. So again, just a little bit longer process. So step number 3 is to find the derivative of the original function at x sub 0, which is 8. So this just means, we'll write right here, f prime at 8, and it just says take the 8 and plug it into this thing. So this gives you 2 over the square root of 8 minus 4, which would be 1 over 2, and this would be 8 minus 4, this would be the square root of 4, which would be equal to 1 over 2 times 2, which would be equal to 1/4. And what this is going to be the derivative evaluated at x sub o, which was 8. So you've got this. Now this is not the answer to the question. You still got one more step to go. So let's go back up here. Right now what you know is this. You know that this is equal to 1, and you know that this thing is 1/4. So the derivative of the original function, and what that tells you is the slope of this line right here is, and this is f prime, is equal to 1/4. So the slope of this one is going to be the reciprocal, and we'll go ahead and put that down here as a 4th step. So the last step, step number 4, is, and again, we're just using our definition. The definition says this, that g prime at 2 is going to be equal to 1 over f prime at 8. And that is, that's right. So g prime evaluated at 2 is equal to 1 over f prime evaluated at 8. So what that's going to be would be 1 over 1/4, which is going to give you 4, and that's going to be the derivative of the inverse. So we'll go back up here again. If the slope of the original function was 1/4, the slope of its derivative is the reciprocal of that, which is going to be 4, and this answer right here is exactly the same answer that you got right here. Again, which method is easier? Well, in my case, I think if you just look at them, the first method is in this case a lot easier. 3 steps, you get right to the answer, and you found the inverse of the original function, found its derivative, evaluated the derivative at x equals 2, and you were done. But that was, again, if you look at the graph, that was mainly doing most of the work with the red graph and the inverse function. Now, when you use this method, all the work is done on the blue function, and you find the slope of the tangent line of the blue function, then the tangent line of the red function is just the reciprocal. And it actually took 4 steps. We'll kind of run out here and take a look at them again. So the idea is you found the derivative of the original function, you found the point that you needed to evaluate the derivative at, you evaluated that derivative, this gives you the slope of the original function, and then finally, the slope of the derivative is just the reciprocal. So that's 2 completely different methods. Now notice, when you look in the book, this method right here is what you're going to see, and it gives you the impression that you should always use this method. And I want to use this example just to show, in a lot of cases, if it's easy to find the inverse function, you're usually better off just finding the inverse, finding its derivative and evaluated, and not using this method at all. But as you'll see in the next video, we'll look at another example. Suppose you had a function that it was difficult to find the inverse or impossible to find the inverse. In that case, you can't use this method because you can't find the inverse, and you'll have to use this method. And that's what we'll look at in the next video.